Hey Internet peoples, I wanted to make a few videos on brake rotor design. The brake rotor is the most important part in any high-performance brake system for objective performance, and I wanted to go over some of the things that make one brake rotor better than another. The first one we'll take a look at is vane design. Let's take a look at some brake rotors and I'll show you what I'm talking about. So I got a few examples of some brake rotors here. These are all ventilated rotors. That means the rotors have an air gap in between here with some vanes, and we'll talk about those. We're not going to talk about solid rotors, which are pretty rare on modern cars. We're going to be talking about ventilated rotors today. So in general, if you're watching this, you're probably nerding out on brakes. You know that the brake rotor takes the energy of your moving car, turns it into heat, and that heat goes into the brake rotor, and then the brake rotor's job is to get rid of that heat. And one of the ways that brake rotors do that, and some better than others, is something called vane design, and that's what we're going to talk about. So this rotor right here is a rotor from my Volvo, and it's a pretty typical OEM rotor. I've drawn with a Sharpie here what is actually inside here, and those are called vanes. So the vanes of the rotor, they spin around with the rotor and they act like a radiator does. The air goes through it and they transfer the heat from the rotor into the air. The faster that the brake rotor can get rid of heat, the higher performance a brake rotor it is. And these vanes are called straight vanes, and you can see why. They're cast into the rotor and they're straight. And as the rotor spins on the car, air actually flows into the back here behind the heat shield and goes inside the rotor, and then it comes out around the periphery here. And that air transfers, it gets warmer as it goes through the brake rotor and cools the brake rotor down, transferring heat out of the brake rotor into the air. And there are some advantages and disadvantages to this very simple design with these straight vanes. The straight vanes are easy to cast, and if you might notice, because they're straight, this rotor can be used on the left or right side of a car. So a manufacturer can make one single rotor that goes on both sides of the car. And the number here, I noted how many vanes there are. So there are 42 vanes in this rotor. In general, the more surface area that you have and the more vanes you can squeeze into this area within reason, then you'll get better performance from the rotor. But it becomes harder and costs more money to put more vents in the rotor in the casting, so there's a trade-off for cost there. Now, the next rotor here, let's talk about this one next. This is what's called a pillar vane rotor. So the designs can vary. This one almost looks like vanes, but you may not be able to see it in here. But if you look in, you may see that it actually looks like kind of pierced vanes. But there's many different designs, but basically these are considered pillars. And pillar vane rotors are another way to do rotor vents. We'll talk about the disadvantages in a minute when we've talked about all the different types of vanes. But the pillar vane are generally not the best performance, but they are favored by OEMs because they make rotors very stable dimensionally, so they don't deform or warp. But there are some particular advantages, and there are some high-performance brake makers like DBA that make a kangaroo paw pillar vane, and that is considered pretty high performance. You know, their claim being that it works as well as the next rotor, which is kind of the gold standard of vane design, if you believe the internets. And this is what's called a curved vane. So it works very similarly to the straight vane, but the vanes are curved. And what you'll hear is that the reason why the vanes are curved is that they act like an air pump, and the claim being that they pump air faster through here and therefore work better. So two problems with that. Actually, any vaned rotor is an air pump. So the explanation that somehow a curved vane acts like an air pump is crap, basically. The straight vanes work exactly the same. They take in air in the center and they tend to throw it out to the side. Now, the part that is true in that explanation is that the curved vanes, and these actually curve towards the back of the car, so this rotor would rotate in this direction. And the efficiency of pumping air through the rotor with curved vanes, it actually is more efficient. But we don't actually care about how fast the air goes. We care about how much heat it transfers to the air around it. And there is actually a couple other reasons why a curved vane rotor is generally superior to any other type of vane for performance applications. And that's actually has more to do with geometry. You can see this rotor compared to the straight vane rotor I have over here actually has a smaller, it's called annulus or depth. But within that area, the vanes are actually as long, because the straight line, as we know, is the shortest distance between 2 points. But with the curved rotor, we can make the vanes actually longer and have more surface area for the same size of rotor. And that's one of the main advantages. The other advantage is simply weight. If we have curved vanes, they're longer. It takes more iron to make them. And when we're trying to concentrate a lot of mass in a small area to get the performance we want out of a rotor, it's useful. And one of the other sort of things that you hear is that there are some OEMs, like I think Audi and Chevrolet on a Corvette, they actually make rotors like this, which you can't make these rotors for both sides of the car. If we made this rotor to go on the other side of the car, since we has to rotate this way, we have to make another rotor with the vanes going the other way. And because they have to do that, that means making a rotor like this is more expensive, because you have to make a part for the left and the right side of the car, versus a straight vane rotor. You can make one rotor for both sides of the car. But there are some cars, the Audi and I think it's an S4 and a Chevrolet Corvette, where they have curved vane rotors from the factory, and they actually run the same rotor left and right. So they run the rotor in what you would consider backwards, where these vanes are spinning into the front of the car like that. And the charge is that you're wasting the benefits of the curved vane rotor, but that's not particularly true, because you still get the benefits of the longer vane, and you're getting the benefits of the increased mass for the same size. So there is a reason why OEMs do that. They're certainly being cheap, but they're still getting the benefits of a curved vane rotor even when you run it backwards. Now lastly, to come back to the pillar vane rotor. So a pump that has holes in the vanes is not really going to give you great airflow. But that really highlights what is actually the secret of the pillar vane. The pillar vane has the benefit of increasing what's called turbulence of the air through the pillars. And turbulence is actually your friend when you're trying to improve heat transfer. So the pillar vane doesn't actually pump air all that well, but because it mixes that air up with more turbulence, it actually transfers more heat than the other rotors do with a less amount of airflow. So pillar vane rotors actually perform pretty well. But other than specialized designs like a DBA, or I think Brembo makes a PVT pillar design, without specific design, pillar vane rotors are generally designed for OEM applications to be dimensionally stable so they don't warp and deform. And that's really the main benefit of pillar vane rotors other than special rotors. So I hope that was helpful. To talk about the basics of brake rotor vane design today, I'll see you in the next one, and we'll talk about the next part of a high performance brake rotor. See ya!